Welcome to Friday lecture. We're going to be talking today about conditional statements and iteration. I have a bunch of announcements, mostly pretty standard stuff. One that's not, we have a form where we're requesting your response about the midterm. And we're asking everyone to fill out this form. So if you haven't already filled it out, please fill it out today. We're going to close it today. In this form, you can indicate whether you can make the standard time, whether you need the alternate time, and whether you need a quiet space to work on the midterm if you don't have a quiet space of your own. Homework 5 is going to be out later today. It'll be due next Thursday, as usual. As always, 5 bonus points if you tone it in early. Project 1 checkpoint is due today, so don't forget to submit. And the full project will be due on October 1st, so a week from now. I want to also mention a change we've made to office hours. We've changed the afternoon office hours to be a hybrid model where you can show up in person or you can get help online. This is an experiment, so feel free to give us feedback about how it's going. What we're doing right now, and probably will continue, is that we're giving precedence to people who are there in person. So if there's anyone there in person, we'll help them. And if we've helped everyone there in person, then we'll start working down the queue of people who are online. So if you're thinking you might like to get help online in the afternoon office hours, you might want to plan ahead. I expect that like the day of the homework or project is due, or maybe the day before, might be particularly busy. And so there might be a long wait for the afternoon online office hours. Yeah, thanks for the feedback, and feel free to give me more about whether this is working well or not. All right, so I want to start by telling you about comparisons in Python. And comparisons lets you compare two numbers or two things in Python. Comparison expression is an expression. It gives you a result. It evaluates to a result. And what it evaluates to is a bool. A Boolean is named after this early mathematician. I think it was George Boole, maybe. What this is it's a simple value that can be either true or false. Okay, so either the condition does hold or it doesn't. You can have a bunch of different kinds of comparisons. You can compare whether x is greater than 1, whether x is greater than y. This angle equals, that means y is greater than or equal to 3. So if y was 5, that would be true. If y was 3, that would be true. But if y was 2, it would be false. You can compare two things for equality using equals sign. You can compare whether they're different with, it's pronounced not equals, this exclamation equals. So x not equals 2 is true if x is anything other than 2. And finally, a funky kind of comparison. You can write something like 2 less than x less than 5. And that will be true if both 2 is less than x and x is less than 5. So for instance, it would be true for 3 or 4, but it would not be true for 2 or 1 or 6. One tricky bit is be careful when you do a comparison for equality. The equals, the double equals indicates to Python that we're doing a comparison. The single equals indicates we're doing an assignment. When you do comparisons, well, let's look at some examples of some comparisons. So some very simple comparisons. 3, I can type 3 greater than 1, and Python tells me true. That evaluates to true because 3 is larger than 1. So let's look at the type of what that evaluates to. It evaluates to something called a bool. So a bool is Python's name for something that's either true or false. In Python, true is spelled true with a capital T. If you try to spell it with a lowercase t, it doesn't work. So capitalization matters. You can do other kinds of comparisons. You can compare for equality. So 3 is equal to 3, but it's not equal to 4. What if I inadvertently tried to compare 3 to 3 using a single equals? Then I have a problem. Python gives me an error message, cannot assign to literal. What does that jargon mean? Well, it sees a single equal sign and it says, oh, I know, that means this is an assignment statement. And in an assignment statement, before the equals is the name of a variable. But wait, 3 doesn't look like the name of a variable, that's a number. Something's off here, and Python gives you an error message. So if you get an error message like that, it'll remind you that the way you do a comparison for equality is with equals equals, with a double equal sign, not a single equals. You can test for not equals. 10 is not equal to 3, so that gave me true. All right, let's do some more. I'm going to assign x to 14 and y to 3. I can compare x to 15, and the answer will be false. Does x have to be an integer? No. Let's try it. Okay, false. So you don't have to compare just ints. You can compare floats. We're going to do a lot with numbers, though. If I write 12 less than x, the answer is true because 12 is smaller than 14. If I write x less than 20, that's true because 14 is indeed smaller than 20. All right, what if I write 12 less than x less than 20? That's also true because 12 is less than x and x is less than 20. Those are both true. So why this funny syntax with multiple less than signs? This is kind of a convenient way to express that x is between 12 and 20, but not inclusive. What if I wanted to express the condition that x is between 12 and 20 inclusive? Like I want 12 to count and 20 to count, as well as 13, 14, 15, 16, and so on. What would I write then? Yeah, use less than or equal to. In other words, this, right, the angle bracket equals. So same thing as before, but replace the less than with less than or equal to, and on both sides. Okay. Good, good, good. Now, you can compare arbitrary expressions. It doesn't have to be just numbers or names. For instance, I can write something like this, and that'll work too. Python evaluates each of these expressions before doing the comparison. In this case, x minus y evaluates to 9. No, 11. It evaluates to 11. 14 minus 3 evaluates to 11, and that is indeed in that range, so I got true. There's another way I could write this comparison. The other way I could write it is like this. I could put an and in there. When I have an and is a way to combine the results of two comparisons. So Python first checks whether 10 is less than x minus y. That's true. Then it checks whether x minus y is less than 13. That's true. Since they're both true, and says output true if both of these are true. If they're not both true, then output false. Okay, so this is a way of combining bools. And you can see that this expression with an and is equivalent to the shorter expression I had up here with this kind of concatenated less than stuff. If one is true and one is false, does the result come out to be false? Let's find out. Suppose we write 3 less than 5 and 100 less than 4. All right, the first one should be true. The second one should be false. What do we get? We get false. So this is true. This is false. And then the and of them will give you true only if both of them are true. So if one is true and one is false and you used an and, the result comes out to be false. Yes, you can use or. Or will give you result will be true if either of them is true. Okay. The next thing I want to show you is that a common thing we're going to do is we're going to have an array, and we may want to do some comparison on every element in the array. You can use these comparison operators on arrays, and they will do a comparison to everything in the array. Then a common next thing we might want to do is take those results and figure out how many of them were true. And you can do that by, there's this little trick. It's kind of obscure, by summing the bools. So if I have a bunch of Booleans and I want to count how many are true, this is a little weird, you can add them up. And Python defines adding up so that when you do the adding, true is like 1 and false behaves like 0. So if I have true plus false plus true, Python will give me the answer 2. Why? Because true gets treated like a 1, false gets treated like a 0. So this gets treated like 1 plus 0 plus 1. And we know that if you add 1 plus 0 plus 1, I get 2. So this is kind of handy. If I have a whole bunch of bools, I can add them together, and the result will be how many trues there were. See, I had 2 trues. Each one contributed 1 to the sum. All right. So if I have an array of 1s and 0s and I sum them up, that tells me how many 1s there are. Very similarly, if I have an array of trues and falses and then I sum them, the sum will tell me how many trues there are, because the trues get treated like 1s and the falses like 0s. This is actually a list. I said array, but I should have said list. Thank you for the correction. So this summing thing works with both summing up an array of bools and with summing up a list of bools. So let's see this in action. It's going to be kind of handy. Let's make a sample array. Well, it would help if I ran that cell at the top. Then that would spare me from getting an error about make array. If you ever get an error like this about some operation that we provide, what that error is telling you is probably that you forgot to run the cell at the top of the notebook. So I just ran the cell at the top of the notebook, and let's try again. Okay, this time this was successful. So let's look at what's in the pets array. You can see the pets array is an array with a bunch of strings. Now let's look what happened if I do a comparison between the pets array and a single string. Python will automatically say, oh, I think what you want to do is you want to compare every item in that array to this string. Okay, so it will compare cat to cat, and then cat to cat, and then dog to cat, and then cat to cat, and then dog to cat, and then rabbit to cat. And it'll give you a new array with all of the bools that come from those. So now I have an array of these bools where trues indicate positions where there was a cat and falses indicate positions where there was something else. Now, suppose I wanted to count how many cats there were in that array. Well, what I can do is I can do this. That's a really cutesy way to do it. So what's happening there? What's happening is the sum operation is adding up each one of the items in this array. And it might look weird to be summing up something that isn't a number, but Python helpfully converts the trues to 1 and the falses to 0. So when I do this sum operation, what Python is actually doing is it's doing this true plus false. And to do that, the way it's doing that is it's converting the trues to 1s and the falses to 0. So it's actually doing, I just did that conversion, and it's actually doing this sum. And then it got 3 because it's adding up 3 1s. All right, so what it did was it formed an array of the results of the comparison. This evaluates to an array with trues and falses, and then it summed up that array. Okay. So this is an idiom that you'll see a lot in this class. If I wanted to count how many dogs there were in that array, I could write it like this. There's an equivalent way to do this. Maybe if you don't like this summing trick, there's a function called np.countNonZero, which does exactly the same thing, but maybe it's easier to read as an indicator that this is counting. Okay. Just one more example of doing these kind of operations, comparison operations in arrays. I can make an array that has a range of numbers. So here you can see this array has the numbers 20, 21, 22, up to 30. If I now do a comparison on that array, Python will compare each item in this array to 28 and give me a bunch of falses and trues. So you can see I get a bunch of falses for the numbers that aren't bigger than 28, and then 2 trues for the ones that are bigger than 28. Okay, let me pause to take a look at the questions in the chat and any other questions you might have. Does this work with lists? Let's try it. You can see it does not work with lists. So when you want to do something on all the elements of a list, you can't do that. That's what arrays were invented for. Another example, if you wanted to add 1 to every item of this list, doesn't work. But if it was an array, you could. So arrays will automatically do something to every item of the list for you, but lists don't do that in Python. What does np.countNonZero pets equals dog do? Well, let's figure out what it does. First, it forms the array that's obtained by doing this comparison. So the array we're going to get here is a bunch of arrays of trues and falses. A true for each position where there's a dog in the pets array, and a false in all the rest. Then np.countNonZero expects an array. It expects an array of numbers, and it counts how many items in that array are non-zero. In this case, we're giving an array of bools, not numbers, but Python will convert the bools to numbers. It'll convert true to 1 and false to 0. So the trues are non-zero. So counting the number of non-zero items is counting the number of trues. So this is counting how many trues there are in the array we get from this comparison. And another way of saying that is we're counting how many items there are in pets that are equal to dog. What's the greater than or equal to comparison? It's you do greater than sign, equal sign. Means greater than or equal to. Wouldn't the falses also be non-zero technically? No, because Python first converts the trues and falses to ints. It's just kind of a funky little thing that count non-zero is expecting ints, and so Python converts them to ints, and the falses convert to zero when you convert to an int, and then there's zero there, so the falses don't count as non-zero. I understand where you're coming from, and it's a perfectly reasonable thing to expect, but it's not quite how it works. You can use np.count 0 to find the false values. Ooh, I don't know. I've never tried that. Let's try it and see if it works. No, there's no count 0. Nice idea. So if I wanted to count the number of false values, does anyone have any ideas what I could do? In other words, count the number of non-dogs. Yeah. I could reverse the comparison. So I compare for things that are not equal to dogs, and then now counting trues is what of the not equal to is equivalent to counting falses for the equals. Great. Okay, next thing I want to show you is conditional statements. We've been showing you Python statements that always get executed, but there are cases where it's useful to have a statement that may or may not be executed depending. All right, so we do that with an if statement. In general, a control statement is any statement that affects which statements get executed. So we're going to look at an if statement, we're going to look at a for statement. They both affect what statements get executed. If statement helps us define functions that will behave differently depending on what their argument is. So let me show you an example of an if statement. I could set this name X, assign it to 20. Then I could have an if statement. So here's what an if statement looks like. If statement has the word if. Then there is an expression. And this should be an expression that evaluates to a bool. Then there's a colon. The colon indicates the end of that expression. Then we put another line, and we have an indentation here, and then some code. So this code, this is a block of code. We think of it as like inside the if statement. This block of code, in this case, it's one line of code, will get executed if the condition is true. If the condition is false, this line of code won't get executed. Okay. So this is saying, if X is greater than or equal to 18, execute the line of code that prints you can legally vote. You can see here's another one that says, if X is greater than or equal to 21, execute the line of code that says print you can legally drink. So X was 20 here. It is bigger than or equal to 18, but it's not bigger than or equal to 21. So we executed the first print statement, but not the second print statement. So in the second one, because the condition was false, this if statement did nothing. It just completely skipped it. It was kind of as though we had nothing there. The statement was not executed. As a result, nothing was printed. The indentation is necessary. Yes. What does the indentation indicate? Well, the indentation gives us a way to have multiple statements that will either all be executed or none be executed. So let me give you an example with two statements, a block of code with two statements. All right, so there is a if statement with two lines of code in the block of code. If the condition is true, both of these lines of code will be executed. If the condition is false, neither will be executed. Now, why do they need to be indented? The indented is how Python tells where this block starts and ends. If they weren't indented, it wouldn't be sure whether, well, let me just give you an example. If I wrote like this is different. This is saying maybe or maybe not do the first print statement and then always do the second print statement. That isn't what I wanted. I wanted maybe or maybe not do both print statements. Okay, so that's what the indentation indicates. It indicates which statements are controlled by the condition. If the condition is not met, then none of these statements are executed. Why print but not return? I wanted to display a message. I could have had an assignment statement. This is not part of a function, so you can't use return. You can only use return inside a function. Can you use else if? Yes, you can. If the condition is not true, you can specify something to execute if the condition is not true using else if. All right, so let's see an example of this. I'm gonna do an example to simulate something. So let me introduce for you the notion of actually, let me do a little more demo first before I introduce random selection. Okay, so I want to do a little demo. We're going to simulate a game, a really simple game where you roll a die, I roll a die, a fair six-sided die. And if my number is bigger, then I win and you pay me $1. My number is smaller, I lose and I pay you $1. And if they're the same, there's no payments happening. What we're going to try to do is we're going to try to simulate doing this game 10,000 times and see how much you win or I win. All right, so let's figure out how to write some code to do that. And I'm going to build our way up to that. So the first step is we're going to find a way to simulate 2 dice rolls, meaning simulate doing this once. And I'm going to put that in a function. I'm going to want to do it many times. So I'm going to put it in a function to make it easy to do many times. So I need a name for this function. This function is one iteration of the game. So let me call it one round. You think of like 99 bottles of beer on the wall, 99 bottles of beer. We call that a round, right? And then the round gets repeated. All right. And so I'm going to define a function. I'm going to call it one round. So this function, when I call it, is going to simulate one round of this game. You roll a die and I roll a die and we figure out how much got paid. This function is going to return how much I win, how much you pay me. So I guess to figure that out, we need to know what I rolled. We need to know what you rolled. So the function is going to need to know that. So those are arguments that are going to need to be passed to that function. Now, how much do I receive in payment? Well, one case is if my roll was bigger than your roll, then I should receive $1 in payment. So this function should return $1, indicating I received $1. So let's try that. And let's try testing this function and see if it seems to do the right thing. So let's test what it does. If I rolled a 4 and you rolled a 3, this function says I receive $1 from you. Does that seem right? Yeah, my roll was bigger, so I should get $1. Let's do another test. Let's say I rolled a 2 and you rolled a 6. Look at the result of this function. There's no result. Did this function do the right thing? That's right. It's not returning anything because the condition is not met. Right on. Yeah, it's not working. It's doing what I the computer is doing what I told it to do, but that's probably not what I want. What I want is to return how much I get paid. And if I lose, then I'm not getting paid anything. In fact, I'm paying you. And a way to represent that is rather than me getting paid $1, it's me, like rather than me paying you $1, an equivalent way to think of that is I got paid -$1. So my profit this round was -$1. So what I really would like is to get -1 back as the result here. But my code here didn't tell the computer to do that. So the computer didn't do that. So my code isn't quite doing what I want yet. So I'm going to need to make an adjustment to this code. So let's try again. So what I now want is, I want, if my roll is smaller, then I want this to return -1. Okay, so there is a way to do this in Python. You can have something called elif, E-L-I-F. What that means is if the first condition was not true, let me give you a second condition. It's like saying otherwise if second condition. Okay, so if the first condition was not true, otherwise, if your roll was bigger than my roll, then return -1. My profit was -$1. All right, so now let's try this again and try testing it on some sample cases. If I got a 4 and you got a 3, my profit is $1. That's good. If I got a 2 and you got a 6, profit is -1. That's good. Let's try one more. If I roll a 3 and you roll a 3, no result from this function. Is that what we want? Not really. Yeah. Really like it to tell me what my profit is. And in this case, my profit was 0. All right, so let's try again. Let's fix that up. So how would I fix that up? Right, I need to add something here for this additional condition. So I could add another elif. If neither of those two conditions holds, then last possibility, your roll is equal to my roll. Turn 0. All right. Now we can test this out. And now, if we got the same roll, it'll return 0. There were multiple ways we could have done this. Instead of elif, we could have had else. Because if these first two conditions doesn't hold, the only remaining possibility is that the two rolls were equal. And in fact, for those of you who said we could have written it like this, you're also right. Because when a function returns, it doesn't execute anything afterwards. So if neither of these two statements execute, then this last one will execute. So those are 3 ways of writing code that does the same thing. I think I kind of like this one the best because it's really explicit about what the 3 cases are, but that's personal preference. You can use whichever one you want. So now we have a way to simulate one round of this game. Well, if I know what the outcome of the rolls are, but I would really like Python to roll the dice for me. So we're going to see how to do that next. And then I'm going to ask Python to do it for me a bunch of times, and we'll do that next. But let me pause for questions here. When an if statement is inside a function, use return. When it's by itself, use print. No, not necessarily. Depends what the statement you want to execute is. In this case, the difference that I wanted to have happen was what got returned. So that's why what was inside the if statement was a return. Sometimes maybe I want to do an if statement where depending on something, I either add 2 numbers or I subtract them. Then I would have not a return statement here, but I would have an addition or a subtraction. So it just depends on what is the thing that you want to conditionally do or not do. All right, brief pause for any other questions. All right, let's see how to pick a random number in Python. So we give you a function called np.random.choice, and that will randomly choose a number. Well, a thing. It will select uniformly at random, which is a way of saying that you give it a list of possible choices, and it will choose one of them randomly. And randomly in this case means not just haphazardly or however it feels like, but in a fair way so that each one of those options has an equal chance of being chosen. This is with replacement, which means that if you make multiple random choices, you could get the same result twice. Like if I roll a fair die twice, I might get the same number both times. It's not super likely, but it can happen. You provide the list of options, the list of possible values in an array. So the way you write this is np.random.choice, and you provide the array, an array holding all the possible values that should be choosing from. It accepts a second argument, and the second argument is a number. And if you provide a second argument, then it'll repeatedly make random choices. The number of times it'll do that is the number you specified as the second argument. So let's see this in action. Here I have an array that has two items in it, wake up or sleep in. Let's say I want to randomly decide whether to wake up or sleep in tomorrow morning. I can run this line of code, np.random.choice, calls the function np.random.choice, and passes it the array mornings. And Python then randomly chose from me one of those two options, and it decided tomorrow I should sleep in. I could make another random choice, like maybe I'm deciding whether or not to wake up or sleep in on Sunday morning. Let's execute another cell with that same code. And now the response that I got was wake up. Same code, different result. That's because the result depended on the random choice. And you could roll the same die multiple times and you won't necessarily get the same number every time. Suppose I wanted to make a set of choices, a plan for an entire week. Then I can pass this optional second argument that tells np.random.choice, please repeat this many times. In this case, I'm asking it to do it 7 times. Give me 7 random choices, put the results in an array, and give me an array that has the results of those 7 random choices. So here I got an array with 7 random choices. All right. Suppose I want to count in that plan how many times I'm waking up. You saw how to do that. I can do a comparison operator, which will compare each item in that array to the string wake up. And then by summing that, that will count how many times that comparison turned up true. All right. So I want you to predict what result this is going to give me. I see up here in this array, wake up twice. So I should get 2, right? Wrong. I got 4. What's going on here? I only see 2 wake ups in this array. It's random and I rolled again. Yeah, you see, this cell executed this code that made a random choice. This cell called the function a second time, so it made another random choice, which gave a different random choice, and this time it had 4 wake up. So I could execute this same line of code, and now I get a different set of outcome with only 1. And another weirdness of this is if I wanted to count how many times I sleep in, it's tempting to think that here I said wake up once, so I must sleep in 6 times. But that doesn't work out that way because I called np.random.choice twice and I got 2 different results. So this first result had 1 wake up and 6 sleep in. This one had 5 wake up and 2 sleep ins. Okay, so maybe I really wanted to make one plan and then count how many times I'm waking up in that one plan and how many times I'm sleeping in that one plan. Then what I should be doing is not call np.random.choice multiple times, but just call it once. I'm going to need to remember the result of that one call. How do I remember the result of an expression or a function call? Yeah, assign it to a variable. So I can create a variable, give it the name plan. Call np.random.choice and assign it to the plan variable. And then what's the error here? Okay, anytime you have an error, go down, look at the last line. Has no attribute random underscore choice. Oh, that's because I misspelled. Should be np.random.choice. All right, take 2. There is my plan for the week. Now I can do the comparison. And everything behaves the way I would expect. Indeed, there are 2 days for waking up, 5 days for sleeping in, 2 + 5 = 7. Everything is kosher. So I can use this to simulate, for instance, the roll of a die. Here's the idiomatic way to do that. I make an array with the options. The options for the outcomes of a die are 1, 2, 3, 4, 5, 6. So I could call make array 1, 2, 3, 4, 5, 6. But there's a way that I can do that with a slightly less typing. So I save myself a few keystrokes. It's kind of silly. np.arange 1, 7 gives me the numbers 1 to 7, but not including 7. So in other words, 1, 2, 3, 4, 5, 6. Then if I pass that to the function np.random.choice, it will select from one of the numbers 1 through 6 randomly, which is equivalent to rolling a die. Okay. So remember this game we had where in one round of the game, I rolled a die and you rolled a die, and then we figured out whose was larger? Let's write a function to do that. We now have everything we need to do that. So we're going to roll a die, my die, and assign the result to a name, my roll. And then we're going to roll the die a second time. This will be your roll, and we'll remember the result by assigning that to the name your roll. And then we're going to figure out how much I profited. And I could do that with an if statement, but remember, I already wrote some code to do that. I have code to compute how much my profit is. I call that function one round that we wrote before and pass it as argument results of the die roll. And then I return that. So that's the result of this function. Okay, so I wrote a function. I can now call this function. And when I call this function, it will simulate rolling a die for me, for you, figure out how much profit I made, and I see, oops, I had to pay you $1. I can do it again. It's like as if we played the game another time, and I had to pay you another $1. So I play again, and this time you had to pay me $1, and so on. Notice this has no arguments. You can see it has no arguments because there's an open parenthesis and a closed parenthesis. You don't have to pass anything to the function. That's allowed. So this function doesn't depend on anything. You don't need to give it any information to do its job. Normally that would be weird. Normally the reason we have a function is because we want to do this something many times, but exactly what we're doing depends on some value, and that's the argument. But in this case, it doesn't depend on anything. And it's kind of not weird because it depends on a random choice. We don't need to pass it the random choice. This code will make the random choice itself. Yeah, this is how casino machines work. Internally, they have np.randomChoice equivalent. All right, so now we've seen how to do one round of this game. Now I want to imagine we play the game many times. And for that, I'm going to use an array to collect the results of playing of each round, each time we played the game. All right, so it's going to be useful to build up a longer array from a shorter array. And the operation np.append helps us do that. If I have an array, and then I have a value like a number that I want to add to the end of it, I can call np.append. The first argument is the array. The second argument is the item to append. And this makes me a new array that has all the stuff from the original plus one more, plus that value at the end. Okay. So it's kind of like it makes a copy of the array and then appends one more thing to the end. You can also use this to concatenate two arrays. If both arguments that I pass it are arrays, then what np.append will do is it will give me a new array, bigger array that has first the items of array 1 and then all the items of array 2. All right, so that's append. Let's see an example of that. Let's take two arrays here. Let's look in what's in the first array, what's in the second array. Let's look at what happens when I append these two arrays. I got a new array that has all the items. Let's also look at what happens if I append 6 to the first array. I get a new array that has the items in the first array followed by 6. Let's check what's in the array with the name first. It doesn't have the 6. So this np.append creates a new array with a copy. It doesn't modify the existing array. So if I want to save or use this new array, I have to assign it to a name. Okay. So that's np.append. Now we're going to use that to do this game many times. And the for statement is going to help me simulate the game many times. The for statement indicates that we're going to repeat something multiple times, once for each item in a list or each item in an array. So let's see how this works. I'm going to make an array to hold the results of, well, let me first show you how to do how for statements work. Here's a for loop. This iterates over an array. The array has 3 items in it: cat, dog, and rabbit. This will do 3 iterations, 3 rounds. In each iteration, the name pet gets assigned to the next item in the array. So this for statement is equivalent to running this code 3 times with a different value for pet. The first time pet is set to cat, the second time pet is set to dog, and the third time pet is set to rabbit. And so you can see it prints I love my cat for the first time. The second time it prints I love my dog. The third time it prints I love my rabbit. All right, so the for loop lets you run one line of code many times. Previously, if we wanted to do the same thing a bunch of times, we had to use arrays. This is an alternate way to do the same thing many times. At this point, I'm out of time. So I guess on Monday, we'll continue by showing you how to put all these pieces together and simulate this game, this betting game, this very simple betting game, and simulate the process of doing the betting 10,000 times. Not something you'd want to actually do with a table in front of each other, but the computer can do it very rapidly. Thank you. That's all for today. Great to see you today, and I hope you have a wonderful weekend.